Hello, my name is John Rees. I'm a distance learning student, and I'm going to be presenting my project proposal, Source Code Analysis through Exploring Git Repositories. So I wanted to start by giving an overview of the project. Again, it is source code analysis through exploring Git repositories. So this project will focus on looking at Git repositories and the history of the files within that repository. So now, code analysis provides many benefits, including highlighting problematic source code, metrics on test coverage, and keeping source code clean. So highlighting problematic source code generally revolves around the concept of a code smell. A code smell is going to be something like a God class where the file is just incredibly large and it could easily be broken up into multiple pieces. A very large file could and will most likely lead to lots of commits on that file because it changes a lot. And if a file changes a lot, that file has a very high potential to introduce new bugs. So a code analysis tool that can highlight problematic source code will show you files that might change a lot, which might break a lot, and thus give you some insight into what kind of code may break before it actually does break. Code analysis can also give you metrics on test coverage, and test coverage will show you how much of your code is actually covered by unit tests. Unit tests are much cheaper and easier to execute than functional tests, and they ensure that you don't regress. So if we have, near 100% test coverage, we can be we can have a better understanding of how our code is being changed and being tested. And then lastly, just keeping our source code clean. And generally I refer to this as just standardization of coding styles. So, where braces are, how variables are named, etc. Generally, you want to make sure that code inside of a repository looks like it was written by one developer and not many. So now we have an overview of the problem. Let's dive a little bit deeper and try to understand the problem at large. And I broke it up into about 3 categories. The first is code smells, as I talked about before, where code smells might allude to a bigger problem. That's pretty much the definition of a code smell. I talked about God class, but there are so many other types of code smells. You can have a large method. You can have a variable that's just not named correctly, or just code that just doesn't look right. And it's a tricky area because not all code smells are necessarily the wrong approach. Sometimes, a very large class is the right approach, if you think about it from a config point of view. But even in that case, when we explore the repository, a config isn't going to change much. So even though it is a large file, it doesn't have the other side effect of being changed very frequently. So there are some trade-offs, but through exploring Git repositories, we can actually make that type of distinction. So this will hopefully, find code smells and give us the ability to potentially link files that we think are problematic, and we can dive deeper to see if those files include any sort of code smells and see if there's any sort of refactorings that we can do there. Next up is code analysis in terms of syntax. Obviously, code analysis can kind of come in 2 flavors. There's code analysis for code smells, finding problems within the code, generally having to do with refactoring and structuring our code. But there's also syntax where it's focusing on keeping code consistent. And generally, we have tools to help us with this, including StyleCop and ReSharper. Kind of how I alluded to in the overview is code analysis syntax is important because when you are in a large team and you're working on a singular code base, you want to make sure that the code looks like it was written by one person. You don't want to have developer A coding one module and developer B coding another module, and when you put the 2 modules together, you want them to look like they were written by the same person. The variable placement is the same, private methods on the bottom or on the top. It just makes it a lot easier to look and understand your code base. And the other part of code smells and code analysis is just technical debt. If it is left unchecked, if we don't do any sort of source code analysis, then we get this concept of technical debt, which is an accumulation of easy solutions rather than the best. So technical debt generally means that the product is working as intended in most cases. It's just not necessarily the best way of approaching something. Just a really crude example is if you need to do sorting, maybe a junior dev wrote, a bubble sort for your sorting algorithm, and it might be hard to fix that once you build on top of it and build on top of it and build on top of it. So that bubble sort becomes your technical debt. Now there are better ways to do that. You could use a merge sort or a quick sort, but because it's working, but it might not be the best, it's still your technical debt. And then again, over time, if you keep making those poor decisions, it's just gonna get harder and harder to extend. So with all of these three kind of like sub problems, we're gonna try to fix this through this project of source code analysis through exploring Git repositories. So how is all of this going to be put together? Environment, language, etc. The context. First and foremost, I'm going to write this in C#, and we're going to rely heavily on Git repositories. Obviously, it's going to be a program that looks at Git repositories and the files that are in them. And then the code will be written inside of the Visual Studio 2017 IDE. That'll be the development context. And then on top of that, we're also going to be using the Microsoft Test Suite and then Microsoft Fakes to provide unit testing. As we kind of talked about previously in the overview with test coverage, I also want to make sure that my program is working as expected. So I will be providing a suite of unit tests to make sure that all of my assertions about the output are correct. So now that we understand the problem and the context in which we're going to use to solve the problem, the product objective is simply that we want to provide users with reporting to facilitate early bug detection. We want to allow users to find bugs before they even become bugs. One of the worst things that can happen is to introduce a bug, deploy it to production, and then your customer finds it. Bugs can be hard to find, they can be expensive to fix, going through debugging, going through rollbacks, etc. If we can provide a means to find bugs before they even happen, then that's going to be a great win for our users. So what are the smaller objective pieces here? First and foremost, I need to do some research on Git. I am generally pretty efficient using Git, but not to the extent of actually being able to take a repository and be able to analyze commits. I am much more of a functional user of Git, so this will allow me to actually see how I can pull in a Git repository, put it into C#, put all of commits into their own models and be able to actually use that data. And in order to reach this objective goal, I do have a Pluralsight license as well as Microsoft Academy, so I can watch some videos on how Git kind of works under the hood, and then I can prototype using just some local Git repositories. You can just open up a command line and do git init, and you have your own repository. So it's really simple to do some prototyping. The next step will be to find repositories to actually use this tool against. I'll want something that has an active community backing and that has lots of bugs and or issues. The whole point of this is to find files that might be problematic in the future, and so I want to be able to look at bugs and look at issues and find out which files have a history of being problematic and see if my tool will actually identify those problems, so that there's some sort of assertion that yes, this is actually working, because the files that I think are problematic because they have bugs behind them. As suggested in the project proposal, I'll be doing feature by feature development. There's a lot of features that we can actually include in this project. There's looking at how many commits a file has and how many commits like an author has done and the times and the rollbacks. There's a lot of information that we can extract from commit data. So I'm just going to focus on two features, the most important ones, commit count and probably revert count. Revert count is something rolled back, so that's a definite bug. And then just a commit count of how frequently something is changing. And then if I have more time, then I will go ahead and and I'll add more features. And then lastly, I want to make sure that what I'm stating is actually true, so proof of correctness. And I'm going to utilize Microsoft Test Framework and provide a unit test per feature to make sure that those features are actually working. This is going to be a look into the timeline of the project, kind of how the objectives stated in the previous slide. I'm going to pretty much give myself a week per objective and per feature. So, first we're going to start out in early October, so we've already started doing research in Git, followed by finding repos, some prototyping time, and then start going through our features. And then lastly, we're going to end up with some testing and feedback, because once the project is done, I want to be able to submit it and get some feedback from you, the professor. And then while I'm awaiting feedback, I can kind of start working on the final report and presentation. Last but not least, I wanted to introduce the team. The team will be myself. I am, again, John Reese. I'm a software engineer at Plex Systems.